Hello everyone. This time we're going to concentrate in just one task, apall. This task performs simultaneously two of the most critical steps in spectral reduction, the background subtraction and the spectrum extraction. As a result, we shall pass from a 2D feeds file to a 1D frame. Apall is one of the biggest and most complex tasks in IRAF. Indeed, if I had to choose an IRAF task to take a course about, it would be this one. However, in this video we're going to focus on how to use it independently of the scientific object. You will appreciate, in this case, how it is a rather short task. Just remember to check your literature and your team for the optimum configuration for your celestial body and telescope setup. The first thing we must do is opening our scientific object feeds file. In my case, it is this one, in which we just perform the wavelength calibration. Now we need to find a region with a strong continuum and a uniform background. In my case, this is a bit harder since this is an H2 galaxy and therefore there is almost no continuum. So I need to go for an emission line. For example here, H alpha. And now I need to write down its coordinates. In this case, 2750. You must use these pixel coordinates since it will not accept wavelengths. Okay. We have its coordinates. And now we're going to change some of the default values in the apall task following the guide of Phil Massey et al. Apall can be found in the apextract package. Here we have it, and now first let's go to the default background parameter section, and here we're going to increase the width of the profile centering to 10. Now in the automatic finding and ordering parameters, we're going to reduce the maximum separation between spectra value to 1000. And now we go to the tracing parameters section. And here we're going to activate the trace rejection iterations, but only one. The next one is extraction parameters, and in here we're going to change the background method to subtract. We're going to change the median, and now in the weights you can set the method for the extraction. You should play with these values. In this case I'm going to choose variance, and we're going to use the values from the feeds headers. So in the gain I say gain, which was the keyword from my William Herschel telescope feeds frames, and red noise. Okay, I think that should be all. Remember to save. Nice. Okay, and now we can run this command. In here, the first and second tags are the input and output names. The rest, the red noise, gains, background, and sum, you already know, but we leave them as you may want to play with these values until you are happy with the results. The line parameter refers to the location of the continuum we're going to use for the analysis. In our case, it was the location of H alpha around 2750. And finally, the lower, upper, and extra tags, we shall see that in a few minutes. Now let's just run the command. And we say yes for all the default values. The number of apertures, in my case I only have one object in each file, so 1, and resize yes. Very nice. Let's make this window bigger. And now, in here you have the ideal case. We have a very strong object surrounded by a uniform and flat background. Currently, we are plotting the sum of lines 2755 to 2754. 10 lines, as we said, in the endsum tag. If we were unhappy with this region, we could change it from here using the command line on a new location. For example, a bit below 2700. However, this region is not good for us since the continuum of my object is very close to the background noise. So let's go back. Line 2750. Okay, we could also change the center of the line location with center. But first, let's take a look at it. As always, to zoom, W, E, E. Okay, it seems that the center of this segment is at the maximum, so we're happy with that. However, it seems the segment does not cover all the region of the line. We could change that with the upper and lower tags we saw before. So let's increase the values. Upper, and now let's say this time 25. Maybe that's a bit too much, so upper 20. Okay, and now the lower one. We must type lower, and now it must be a negative values. Otherwise, it'll match the upper one, so minus 20. Remember that it must be the same length at both sides. Now we go back to the whole plot. Okay. At this point, we have properly defined the object's spectrum region. Now we need to define the background level. To do that, we need to press the B key. You can see that this is the background level apall has calculated using these two regions. We are not happy with this background level, so we need to first delete these regions with the key T. Nice, and now we need to select a new one. We can do that with the S key, and we can select as many regions as we want. So S, S, and S, S, and fit again. That's better. If you're not happy with the column range IRAF has plotted, you can replot the whole range with WA. And if you want to select a wider section for the background, as we did before, T to delete, and now S, 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 and fit. Let's zoom over it, WE, E. Very nice. You must be asking yourself which is the ideal selection for the background. Well, in most cases, you want a sizable background region. However, as you get closer to the edges of the CCD, the quality of the recording decreases sharply. If this happens, you should select regions as close as possible to the continuum. You will need to repeat this process several times until you find the optimum region for your total spectrum. Myself, I'm just going to assume this is fine. So I press Q once to leave the background selection and again to leave the spectrum selection window. And now I say yes to trace apertures for my object. Fit trace positions, yes. Fit curve, yes. In here I have the fitting of the spectrum extraction with an RMS of 0.52, which is quite good. As always, however, I can delete some points with the key D. Let's delete some more values over here. And F to fit. The residual has improved. In this window, you can also increase the order of the fitting function Once we are happy with our fitting, we press Q, we say yes again to all the messages, write apertures, yes, extract aperture spectra, yes, review extracted spectra, review yes. Okay, here we have it. As you can see, this is a beauty. At this point, we have concluded the application of the task apall. We can press Q. Let's minimize this window. Okay. Now we have created a 1D file with our spectrum and we have finished an important step. Before ending this video, however, I want to explain you a few things. Let's open this file with splot. In some cases, you will notice how apall will add to this file name an extension like something similar to 0.001. This notation refers to the aperture number. Incidentally, if you have several spectra in each feeds file, you just have to make sure all the apertures have been properly identified and the task will run iteratively for each one. But in our case, since we just have one aperture, let's run this command. Aha! As you can see, splot did not open the window directly. It is asking me which band to plot. As you might remember, in the apall command line, there was an tag named extras, which we activated with a plus sign. When this parameter is activated, it will save several plots in our feeds files. Let's start by plotting the first one. Enter. Okay, this is a spectrum extracted according to the configuration we defined for the apall task. This is the one you want to proceed with for the flags calibration. To see the next band, you need to press the right bracket key. In my case, this is the result of the combination Shift and 9. Okay. Incidentally, you can go back with the left bracket key. The second band is the raw spectrum. It is a bit different from the previous one if you use the variance weighting. The next one, over here, is the sky spectrum. This is the result of the background subtraction. Finally, we have the sigma spectrum. This only appears if the variance weighting is applied, as it is our case. It represents the extraction weighting which IRAF uses to distinguish the background from the scientific object. In our case, it is based on the data from the gain and rate noise parameters from the feed frames headers. This data is useful for the initial application of apall, making sure you get the finest result possible. However, once you're happy with the results, you can avoid saving this data in your feeds files by deactivating the extras flag. Of course, you can keep this data and continue with the spectral reduction, but in that case, remember to add a 1 between square brackets to your file names in the IRAF commands so that the task knows which band to use. In any case, do not worry, IRAF will ask you which band to use if you forget to add extension. Okay, that's all I wanted to show you today. Very good job for keeping up. Thank you for watching and see you soon.